Welcome to Hartman Math. Go Dodgers. Before we get to operations with matrices, let's review a little bit of our introduction to matrices by solving this system using matrices and using the Gauss Jordan elimination. Go ahead and pause here until you're ready to take a look at it. All right, our first step would be to write it in terms of an augmented matrix. 2, -3, 10, 5, -2, 3 is our start. There's our augmented matrix. And then we want to take a look here, and we want that to be a 1, and there's multiple ways of doing it. We could multiply through by 1/2, a non-zero constant. That's operation number 2. That would create fractions, not a deal breaker, but noticing a relationship here wouldn't be too hard to do row operation number 3. Multiply this by a constant and add to the 5 to create a new row 1. So now you would probably want to work down the page. I'm a little bit limited here on space. So I'm going to take this to the side. So I'm going to multiply this by -2, add to the row below, creating a new row 1. So -2 times 2 plus 5 is 1. -2 times -3 plus -2 is 4. And -2 times 10 plus the 13 is -17. So what did we just do? We did -2 row 1 plus row 2. We'll keep this one the same. So we've got our 1. We want to make this a 0. Keep the top row. Multiply by -5 and add. Multiply by -5 and add. Multiply by -5 and add. Did -5 times row 1 plus row 2. So we've got our column 1 is taken care of. So now we'll focus here. And by multiplying by a non-zero constant, we can turn that into a 1. So 1, 4, -17, 0, 1, -4. Multiplied row 3 by -1/22. All right, getting close. This is Gauss Jordan. If this was just Gaussian elimination, we could say y is equal to -4 and do back substitution and solve for x. But Gauss Jordan requires us to be reduced row echelon form, 1's in the diagonal, 0's everywhere else. So we got one more step to go. We're going to multiply by -4 and add. So -4 times row 2 plus row 1. So our solutions, x is -1 and y is -4. This is lesson 8.2, operations with matrices. We're going to begin with matrix addition and scalar multiplication. We've seen this word scalar before when we were talking about vectors, and it's very similar. So with matrix addition, we're going to add the matrices entry by entry. And what that forces us to have is that in order to be able to add two matrices, they have to have the same dimension, the same order, they have to be the same size. So then we would just essentially do entry by entry. So entry 1, 1 here, entry 1, 1 there, add those together, that becomes the new entry 1, 1, and so on. If you're asked to add the sum, find the sum of two matrices that are different dimensions, that would be undefined. So example, we've got a 2 by 3 and a 2 by 3. We can simply just add entry by entry. We can do this one because they're the same dimension. And we do row 1, column 1 plus row 1, column 1. So we're going to get 7, 3, 0, 3, negative 9, negative 3. Now, see if we can verify that with a graphing calculator. So we want to go to the graphing calculator and select matrix. So we're going to go second here to select matrix. And to begin, we're going to want to edit. So arrow over, edit, and we will start with matrix A. So I'm going to select 1. And it asks us what size, what dimension we would like that to be. And our first matrix was a 2, arrow to the right, by 3. Enter, and then we can go entry by entry and put those in. Our matrix was 2, enter, 0, enter. Make sure we jump to the right. Negative 5, enter, 4, negative 1, negative 7, enter. Enter one more time, make sure that that's there. And then we're going to go back into matrix again and edit. And now we want to edit matrix number 2, matrix B. We also want that to be a 2 by 3. And that one was 5, 3, 5. Negative 1. Negative 8. Positive 4. Enter one more time, make sure it's in there. Once our second matrix is ready, we are going to quit. Second mode quit. Kind of restart this. Now we want to choose our matrices. So matrix, we're going to want to do from names. So I'm going to choose matrix A. I want to add that to matrix B. So now I'm going to go back to matrix. I'm going to choose matrix B. Now I'm going to hit enter. There's our answer. All right, checkpoint. Go ahead and pause here. Go ahead and find the difference matrix by subtracting. And see if you can verify that also on the graphing calculator. You should have gotten this matrix here. So our next look is the next operation, scalar multiplication, taking a matrix and multiplying it by a scalar. Just like we had done with vectors, it just means to take each entry in the matrix and multiply by the scalar. Multiply all of them by 5. So there's our product matrix. We could also verify that with the graphing calculator. You can go back. This one was already in our graphing calculator as matrix A. So you could go ahead and go 5, go into matrix, choose matrix A, hit equals, implying multiplication, and it's going to show that. All right, another checkpoint for you here. We want to do 4 times this matrix minus this matrix. Do it on your own. Maybe even play around with the graphing calculator. See if you can verify your result. Come back here when you're ready. The answer is the matrix. 12, negative 29. 2, negative 3, negative 12, 33. Make sure you indicate the brackets to say that it's a matrix. Matrix multiplication is quite different when we multiply 2 matrices together. So the idea of when we take one matrix multiplied by another matrix, we can't always do it. The orders have to match up. Now they don't necessarily need to be the same, order for both matrices. In fact, some of the times, if they are the same order, you can't multiply them. What has to happen is, in the first matrix, the number of columns has to match up and be the same as the number of rows in the second matrix. In which case, the product matrix would be number of rows here by number of columns there, an M by P matrix. So what we do when we're multiplying is we take this row from the first matrix and match it up with this column in the second matrix. We multiply first and first, second and second, third and third, and so on. And then we add up all of those products. That's how we create that matrix. So example number 7. Can we multiply these two matrices? Yes, we can. We have a 2 by 2 multiplied by a 2 by 3. Those match up. So that tells us that our product matrix is going to be a 2 by 3. So what we're going to do is we're going to take the first row here, match it up to the first column. First row, first column creates our entry in the first row and the first column. We would multiply first and first, second and second, and add them together. So 3 times 2, negative 1 times negative 1, and add them together. It doesn't really matter, but I'm going to then kind of proceed across and now do row 1, column 2. Row 1, column 2. First times first, second times second, add them together. Row 1, column 3. First times first, second times second, add them together. Move on to row 2. So row 2, column 1, row 2, column 1, first and first, second and second. 0 times 2, 2 times negative 1. Row 2, column 2, 0 times 5, 2 times negative 2. Add them together. 0 times 0, 2 times 3. Let's see if we can evaluate all these. 6 plus 1, 15 plus 2, 0 plus negative 3, 0 plus negative 2, 0 plus negative 4, 0 plus 6. And then there's our final product. Let's go ahead and confirm that in our graphing calculator. We're going to go back to matrix, and we are going to edit matrix A. We want that now to be a 2 by 2, as our first matrix was 3, negative 1, 0, 2. Hit enter once again on last just to make sure it's in there. And then I can quit, go into matrix, edit number 2, which is a 2 by 3, 2, 5, 0, negative 1, negative 2, positive 3. Hit enter one more time on the last one to make sure it's in there. Quit. Go to matrix. From names, choose matrix A. For multiplication, I don't need to hit the multiplication sign. It's going to know it's multiplication. I'm going to choose matrix B. It knows to multiply them. And there's our product. Let's try one more just to see. We've got them in here. What would happen if we did B times A? So matrix, choose B. Matrix, choose A, equals dimension mismatch. They are not of the correct dimension, because in that case we would have a 2 by 3 multiplied by a 2 by 2, and the inner numbers have to match up, and they do not in that case. Example number 8, find the product of these two matrices. Think about it for a moment based on their dimensions. What's going to be the dimension of the product, or can we even do it? We have a 1 by 3 multiplied by a 3 by 1. 3's match up. We're going to get a 1 by 1 matrix answer. So we're going to go row matched up with column, first times first, second times second, third times third. Four plus 10 plus 18 is the matrix. That's a 1 by 1 matrix of 32. What if we switch it around? Checkpoint. Pause here till you're ready. That one, we got a 3 by 1 multiplied by a 1 by 3. The middle ones match up. The outer 3's are going to be the dimension of our answer. We're going to get a 3 by 3. Match up the 4 by the 1, 4 by the 2, the 4 by the 3. There's your solution. That's it for today. I'll see you next time.